Okay, here we are. It says supermarkets often place similar types of cereal on the same supermarket shelf. Does the sugar content vary by shelf? A box plot and ANOVA table for 77 cereals were shown in the accompanying technology output and were asked to complete parts A through D. Okay, so let's look at our output. Oh, that's very exciting. Okay, so we've got our p-value. Remember, a small p-value indicates that we should reject the null hypothesis. How many shelves do we have? We have 3 shelves, so that must mean why the degrees of freedom for the treatment, which is shelf, is 3 minus 1, which is 2, and then there were 77 minus 3, or 74 degrees of freedom for the error, and we've got our F ratio, and we're kind of looking at this, and it does appear that they have equal variance, so we can go ahead and think that this is okay. Okay, so let's look at this. It says, what are the null and the alternative hypothesis? Well, remember for an ANOVA, it's always that they're the same, the mean sugar content is the same, and then it's not all the same. So that's going to be choice C. What does the ANOVA table tell us about the null and alternative hypothesis? Okay, and so back at this ANOVA table, remember we have a small p-value, and so we are going to be able to reject the null hypothesis. So we will reject the null hypothesis. There is sufficient evidence to suggest that the mean sugar content. Okay. Now, it says, can we conclude that the cereals on shelf 2 have higher mean sugar content than on shelf 3? What about on shelf 2 and shelf 1 and all of that? Well, we really cannot do any of that. All we can conclude is that they are not all equal. That's all the ANOVA table tells us. But we can do a Bonferroni analysis, which has been done for us with a computer, and we just have to interpret it. So it says to check for significant differences between shelf means, we can use a Bonferroni test, whose results are shown below. For each pair of shelves, the difference is shown along with the standard error and the significance level. And so how you would read this is you would say to yourself, okay, between shelf 1 and shelf 2, the p-value is 0.001. So you would reject the hypothesis that they have an equal difference. And notice between 2 and 1, you get the same one. So it does appear that between shelf 1 and shelf 2, let's see also, we're going to do 1 minus 2, and we see how we're in the negatives. So it looks like we have lower sugar in shelf 1 because it would be, because you would do a mean minus a mean and get a negative. So the first number would have to be lower than the second number in order to get a negative. It doesn't look like there's a difference between 1 and 3 because the p-value is 0.158, and also notice 0 is in the confidence interval. So that's another way you can look at it. All right, we already knew about 2 and 1. Let's look at 2 and 3. Between 2 and 3, we have a p-value of 0.009, and we have a positive confidence interval, which makes me think that the sugar content in 2 is higher than it is in 3. Okay, so it looks like shelf 2, right at your little kiddo eyeball level, right, is where the highest sugar content is. Now in 3, okay, well let's look at 3 and 1. Doesn't seem to be a difference. Notice 0's in the confidence interval. 3 and 2, again, it's negative, so the 3 has lower sugar than 2. So let's see if we can put all those words together. Well, let's see, we can conclude that the cereals on shelf 1 have a higher mean sugar count than shelf 3. No, we could not see a difference between 1 and 3 because 0 was in the confidence interval or we had a high p-value, however you want to look at that. Conclude the cereals on shelf 2 have a higher mean sugar content than on shelf 1. Yes, that did appear to be true because when we looked at 1 minus 2, we got all negatives or small p-value, or 2 minus 1, we got the positives. So, okay. Conclude that the mean sugar contents are equal. Obviously not, because we rejected our null earlier. Conclude that the cereals on shelf 2 have a higher mean sugar content than cereals on shelf 3. I think that is actually true. 2 minus 3, notice we have a positive confidence interval, a small p-value. So this is true. And then conclude the cereals on shelf 3 have a higher mean sugar than 1. When you compare 3 and 1, your p-value, so that's a no. So we are basically seeing that 2 seems to have higher sugar than 1 and higher sugar than 3. Okay, so that's that Bonferroni test, which is kind of fun. It's fun to say Bonferroni.